Hello. I am Majid Iqbal, and I am presenting my Excel sheet in which I present oscillating system with different modes, with different parameters, which are mentioned here. You can see that I can change the mass, spring constant, damping coefficient, initial position amplitude, driving force amplitude and driving force frequency, time and phase angle. These are actually the input parameters, and these are the results. Okay, by there are the scroll bar from which I can change the value of these parameters, like spring constant. The value of spring constant is 1 unit. I can change this by scroll bar. Now this is 2. I can increase more. When I increase it, the value of some results changes. By these, I can see the live uh, changes in behavior of oscillator. And there are so many graphs which are on a button. This is position versus time graph. It is sinusoidal graph. This is velocity versus position. That is a phase diagram. This is energy versus time for damped oscillator, and there are other graphs as well. Now, if you see this, the damping coefficient is 0, and that's why the velocity versus position graph is a loop, which means object is written back to the initial position and continue its motion without loss of energy. You can see this is energy versus position. The total energy remain conserved, which can be seen from a green line, which is constant at each point, and this red curve is actually the potential energy. We know that at the mean position it is minimum, and at the extreme position potential energy is maximum. On the other hand, the kinetic energy is minimum at extremes and maximum at mean position. So these are uh, very well described in these graphs. Now, if you add the damping constant by this, I increase the value of the damping coefficient by scroll bar. Now this is 1. Now the changes will appear. You can see these are the changes. The total the energy conservation, total energy is reducing. Green line is going down. It means the energy is lost so quickly in first oscillation, and then it reduces step by step. Similarly for kinetic energy and potential energy curve. Now you can see velocity versus position. Now this is not an circular loop, but this is actually position is decreasing with oscillation, and velocity as well is decreasing. So it starts from the position 1, and then at the other side it cannot reach to -1, then it reached to 0.2, then more nearer to the mean position, and at last it reached to the mean position. So these graphs well explain the phenomena of oscillation. Thank you so much.